Hello and welcome to our conference, to our webinar, to our presentation today. So for those of you that don't know me, who are brand new to this, of which there are many, I have heard, they have told me are people who track these things. Yeah, so welcome. And my name is Dan Kalish. I've been practicing functional medicine for almost 30 years. I have a practice I still run where I see patients 2 days a week. I train doctors and have been doing doctor training programs since 1995, if you can believe that. Kind of an early starter there. Anyways, I was writing up lab-based doctor training programs in 1995. You know how I know the date? Because it was a little bit before my son was born. And by the time he was born, I was literally pushing his baby stroller around. This was in 1998. And pushing his baby stroller around, like taking notes and writing down things and listening to cassette tapes and doing all this stuff, preparing doctor seminars for the same stuff, for adrenal stuff, GI programs, all the things that we're going to be talking about tonight. It's funny. I'm just thinking about him a lot because it's his birthday and I'm taking him out to birthday for a birthday dinner later tonight. He's 23 now, he's all grown up. So I've been doing this for a long time and I really enjoy it. And we have a whole bunch of stuff to talk about. So in terms of my professional background, I've been in practice for a long time, been teaching doctors for a long time. I've had, trainings. I've been the student of some of the great people in our field, from Dr. Bill Timmons, a series of naturopaths that trained me early on in clinical nutrition, and now I'm working really closely with Dr. Richard Lord, who's the founder of all this testing. So Richard was the first person, along with Andy Brawley, to set up amino acid testing. I guess it was like the 1980s or something. I was still in college. I was barely out of high school when Richard and Andy were doing this stuff. It's been around for a long time. Richard and I have been working together for 6 years now, and we talk about this stuff twice a week, every week, and it's really nothing more exciting to me than to talk about amino acids, and I want to thank Richard for all his input. And he has his PhD from the late 1960s was in proteomics, so he's been interested in amino acids and proteins since he was in graduate school in like 1967 or whatever that was. So anyways, this goes way, way back. The history of what we're talking about tonight goes way, way back, 50 plus years, and there's been lab companies doing this work for decades. And I just want to kind of introduce you all to the subject matter because I feel like it's the most important thing. And I don't choose this title lightly either, the building blocks of life. I mean, you could call a lot of things the building blocks of life, but if you don't have amino acids, you don't really have much in the way of the human body, do you? So again, about me, the principal investigator, I did a research study with the Mayo Clinic, which is kind of amazing that that happened. Working with Richard, IFM certified. I've also taught a lot with IFM. I've taught their practice implementation programs for a bunch of years, and really involved in the field in general. And the main focus of what I've been doing, if you really kind of try to summarize all these things that I've been doing all these years is some people are having trouble with their sound. I think the sound is working. If you can hear me, just type in "I can hear you," just to be sure it's not. Okay, okay, yeah. So some people have, you just adjust your computer, it'll work. Okay. Oh, I kind of lost my train of thought there. What was I going to say? Oh, about what I'm really doing. Okay, so well, if I really, I'm kind of a grown up now. I'm 57 years old, and I'm looking back on these last 30 years and thinking, what have I really been doing? And you know, I've been devoted to getting doctors up to speed and running in a functional medicine practice since the early days, since the mid 1990s. Soon as I was doing my practice, I was training other people how to do theirs. And what I've learned over these 30 years is that there's really predictable roadblocks to starting a practice, and they've changed over the years quite a bit. I've watched the profession change, and what is a roadblock now is a lot different than what was a roadblock in 1995. I'll tell you that. But I've made a study of this, and I've worked with thousands of doctors, and I'm really committed to getting you guys, anyone who listens to this, up and running with lab interpretation skills and the business skills you need to have a really successful practice. And I define a successful practice as maybe this is a little personalizing it a little bit, but you should be able to afford at least one good car, because I really like cars. Not like 10 cars, but like one good car, put your kid into a good college, have a decent place to live, and sleep well at night because you're helping the world. So we're not talking about businesses that are designed to make gazillions of dollars. We're talking about businesses or practices that are designed to help gazillions of people. And what Dr. Timmons drilled into me all those years ago was that all of this hinges on your lab interpretation skills and your lab data, and that you really got to nail this one 100%. It's not a lot of options here, okay? It's like you're an Olympic diver, and this is like the most important dive. You got to learn how to do this one. When you're in the Olympic Games, you got to do this one, and you got to nail it with a 10. Lab interpretation skills just have to be honed, and so that's really what I'm focusing on now, and have been for many decades. Getting you guys the roadblocks removed, and getting you all so you can be successful in practice. So we have a bunch of things to that end coming up. We have these lab interpretation boot camps we started doing this year. And we have our second part of the amino acids one. You don't have to take them sequentially. There's just 2 of them. So if you didn't do part 1, you can do part 2. And that's coming up towards the end of October. Pretty excited about this one. I put a lot of energy in it. As you can tell, I mean, it's like 6 years of work with Richard Lord on amino acids, and we've got a couple boot camps for you. So the thing about the boot camps are they're short. They're like a month or 2 or 3. It's a couple months long, right? It's an intensive. It's like a real boot camp when you think about what's a boot camp. Well, you work really hard, but not for very long, right? You don't sign up for like a year-long boot camp. Boot camps are short, intensives, and you come out of it thinking, wow, that was a good workout, right? You get something out of it, and that's kind of the point of these short form classes that we're doing now. And so if you like this talk tonight and you want to use this in your practice, you sign up for this thing. You get like 20% off if you use this code. It's not that expensive to begin with, okay? And it's totally doable. It's a couple months of your time. It's a little bit of money, and you can get up to speed. The code is Mini21. And yeah, these have been wildly successful, and we're doing really well with them, and we're really helping a lot of docs understand how to interpret labs, which is the whole point of this. So tonight's really about an introduction to this area, looking at amino acids, and we're not going to talk too much about fatty acids. We'll say that for a different day. But the goal here is to see, and we're going to look at labs in a few minutes too, okay? So I want to do a short lecture and then talk about the labs. So the idea is to see how amino acids play across all these different body systems, right? How this is kind of a little confusing maybe and overwhelming in a sense, but that amino acids have to do with just about everything in the body. And we'll look at some detail on that. And when I think about bigger treatment model methodology, we're always looking for underlying cause issues. We think about body systems, different kinds of damage, and then we're always trying to relieve symptoms. And somewhere in the middle of all this are amino acids, because amino acids can relieve symptoms. Amino acids build up the body systems. Amino acids are damaged, right, when the body is damaged, and amino acids are often the underlying cause of a problem. And if you want to think really big picture with amino acids, you can think person's low in amino acids because they eat poor quality food, possible. Person's low in amino acids because they don't absorb amino acids very well, possible. Person's needs amino acids because they have a genetic disorder that has to do with amino acids. That to me is the most intriguing part of this, and that's really where this stuff gets exciting, really exciting. And so if you can figure out in the next couple of years in your practice, every single patient that walks in the door that has a genetically based amino acid disorder, you will be like rock star level practitioner. I mean, that's a really big deal to be able to do that. And it's something you can do. I mean, it took Richard training me. So I met Richard after 25 years of practice. Took Richard probably 3.5 years to get me up to the level where I could say I could pretty much spot most genetic amino acid related disorders in my practice now. Not all, but most, So it's not an easy project, but man, once you get this, it really brings this whole other level of understanding to be able to help people, especially people that are chronically ill and have all kinds of complicated problems. And then as much as I love the labs, I also want to kind of pay respect to all the great teachers that I had and to this understanding that there is this doctor-patient equilibrium and that this is really about our patients and their goals and their suffering and relieving their suffering. And it's really about the spiritual and emotional connection that we have with other human beings and how we can make their lives better. And that's the whole point of all this. As exciting as the science is, when it comes down to the end of it, you give somebody a bottle of glycine, you have the guts to give them 6,000 milligrams a day of glycine for 90 days, and they come back and they say, my constipation's gone because now my gallbladder is working because the glycine is required for bile acid production. And they say my energy levels are back because glycine is required to make hemoglobin, and now they're transporting oxygen better. And then they say, and my skin problems are completely gone because glycine is required to make glutathione, which is a potent antioxidant that helps protect the tissues, including the skin, right? And all these things happen, and you're just like, poof, I nailed that one. That was a really good experience, and that's where we want you to be, where you're in this kind of service to other people, right? And then we're just gonna kind of briefly touch on some of the bigger picture things that we teach. But in my mentorship course, if any of you ever take that, it's a year-long class, and we go through all of these different treatments and show you how to sequence them. But I just want to point out that what we're looking at tonight is a small subsection of the total. So if somebody's asking the question, well, why are these amino acids low? I don't know. We only got like 45 minutes. We can't cover all that, right? It could be a gut problem. It could be genetically based. I'm going to give you some examples with the labs, but there's it's almost like there's more questions than answers that are raised when you do these kind of short classes, right? And now let's look here. Now this is really, really important, and I didn't know this until like 5 or 6 years ago. And this is like proteomics 101. I don't think I learned it and forgot it. I think just nobody ever told me. And this is a page, literally a page out of Richard's book, not a metaphorical page. Human protein amino acid composition, and there's the citation there if you want to look at the study this is from. And okay, the reason why this is really, really important is because there are 20 amino acids that are required to make all proteins in the body except for collagen. Collagen's a little weird, but except for collagen, every single protein in the body needs to have all 20 of these amino acids present. There's no negotiating here. You cannot, if you're low on lysine, you're low enough on lysine, you can't make proteins in the body, any proteins. And if you believe in metabolism, if you believe that metabolism really makes a difference, then you've just eliminated everything about metabolism just because you're low on lysine, because now you can't make any of the enzymes that run your glycolysis, that run your beta oxidation, that help you burn carbs, that help you burn fat. Your entire mitochondrial system is just shredded just because you don't have enough lysine. Okay, because every single one of these 20 amino acids is required to make every single enzyme in the body. And the interesting thing about this human protein amino acid composition chart is you can see they're listed in the order of volume in which they exist by volume. So methionine, we get a lot of, and tryptophan, you just need a little bit of. But if you miss that tryptophan, you can't make the protein. So tryptophan is often considered by people in proteomics as the rate limiting step in the synthesis of all proteins except for collagen, because it's the one that you need only a tiny little bit of, right? It's at the smallest percentage. And if it's fluctuating in amounts, even small amounts, it can be catastrophic. So when you think about tryptophan, you think, what's the most important thing about tryptophan? It's the fact that it's required for protein synthesis. That's what makes tryptophan so important, okay? And the vast majority of tryptophan in the body, the vast majority of it, like 90% of it, is heading over to do what? It has nothing to do with serotonin. It's doing protein synthesis. It's making proteins. It's only like 10% or something like that of tryptophan goes off and does other stuff like makes serotonin. Okay, and out of the serotonin that it makes, out of the serotonin it's made, only a few percentage of that percentage ends up in the brain anyways, right? So tryptophan's main role in the human body, protein synthesis. So we want to retrain ourselves. If you're experienced in this field and you've done a lot of work with amino acids, you want to just retrain yourself to think, okay, wait a minute, what's the main role of tryptophan in the body? Not serotonin production, that's peripheral. You can live a really long time and be depressed. And in fact, half of America is doing that right now, right? They're depressed and they're still alive. But you can't live very long without protein synthesis, and that's really what today's talk is all about. And then there are, okay, now this is going to get confusing because I just said protein synthesis is the most important thing, which is true. But then we also got to talk about another page from Richard's book, Dr. Lord's book, right, which is symptoms associated with impairment of non-protein functions of amino acids. Most important thing those 20 amino acids do is make proteins. Okay, they do other things too, right? And here's a nice list of some of the other things. And this is a short, obviously incredibly short list, right? So arginine is important for, mostly important for making proteins, but secondarily, well, it gets that ammonia out of your brain. That's convenient because if ammonia builds up in a patient's brain, they don't feel very good. It's the precursor to nitric oxide, which keeps your blood vessels healthy. You could look at methionine and cysteine. Their function is to help produce glutathione. Okay. You could look at lysine, which is talked about. Lysine is a precursor to carnitine. So lysine is required for you to burn fat. You take lysine, you make carnitine, you use the carnitine to burn fat. If you don't have the lysine, you can't make the carnitine, you can't burn fat. So that's a non-protein function of amino acid of lysine. But what's lysine's most important role? Just like tryptophan, protein synthesis. All proteins, right, in the human body. Again, here's another good example, tyrosine. It's most famous as a precursor to the thyroid hormones. It's how you make your epinephrine, norepinephrine, and dopamine. So if I said tyrosine, most of you probably would think, oh, well, that's really important for thyroid and for the brain. But what's the most important role for tyrosine? Protein synthesis. Richard got me on this one for like 2 or 3 years because he knew I would forget, and then it's like a few months later, and he's like, "Oh, so you've got this patient, Dan, and they've got low glycine. Okay, well, let me tell you. Let me ask you a question, Dan." And then I'm thinking, okay, I got to get this right. What are the roles of glycine in the body? And then I would say things like, "Oh, well, it helps you make hemoglobin. I know if you don't make hemoglobin, you can't transport oxygen. Oh, we had that case a few months ago where I now know that glycine is required for making bile. So if you don't have enough glycine, your gallbladder doesn't work. You can have SIBO from a lack of glycine. In fact, I've had more patients than I can count that had SIBO because they had a lack of glycine, because the lack of glycine meant they didn't have enough bile acid production. The lack of bile acids allows the bacteria in the small intestine to proliferate. So of course they go crazy in the small intestine, get all these bacterial overgrowth problems. So I'm thinking along these lines, right? And I'm speaking really fast right now because that's kind of how my brain is working. And then he's just waiting and sitting there. And then I realize, oh no, he tricked me again. And I'll say, oh, wait a minute. The most important role of glycine, the main reason why glycine is in the human body is for what? Protein synthesis. Okay, so we're just trying to hold these two incongruous thoughts. The fact that you need all these amino acids to make proteins, which amino acids? Here's the list. And the fact that these individual amino acids do special things too. Okay, that's super important. And then the non-protein function means, other things besides making protein. Maybe we should talk in a minute too about the single carbon pool. If you haven't heard of that, you could raise your hand metaphorically. I can't really see you, but you could raise your hand if you've heard of methylation. Okay, everybody put your hand up if you've heard of methylation. Okay, now I want you to put your other hand up if you've heard of the single carbon pool. And I don't know how many of you have both hands up, but you could type in a note there or something like that. Okay, that's a hard one, right? We're going to look at that in a minute and talk about also what methylation has to do with glutathione. Okay, so you need amino acids to make this single carbon pool to methylate, and methylation and glutathione production go both. Oh, good, Paula had both hands up. Thank you, Paula. Someone got that. Okay. Now, this is kind of an abstract slide, but I'm not even saying I begin to understand this slide, but I'm beginning to understand that this matters. So I'm just going to throw this out there. I'm going to spend 30 seconds on it. This is just something you should put it in the back of your mind and think about maybe like a year from now. Okay, that what we're actually measuring on the test, it's done fasting, right? It's a blood test. It's done first thing in the morning, and we're measuring amino acids, but the person hasn't eaten for a while. So we're not measuring what they just chewed on and swallowed. We're measuring the inflow and the outflow of amino acids. And the inflow is coming from all kinds of things, like your body makes amino acids, believe it or not. Your body breaks down cells and tissues and releases the amino acids into the bloodstream. And then your body's constantly using amino acids to build up proteins and stuff, right? And so what we're measuring is this flux of amino acids moving in and out. No patient will ever ask you this question, but it's just something that you should, in the abstract, think about. okay? And then I have these lists, and I want to show you amino acids and catecholamines, amino acids and toxicants, amino acids in your heart, amino acids and glutathione, amino acids and glutathione again, and then amino acids and methylation, and then methylation matters, and then protein functions, and then I'm going to show you some of this stuff, and then we're going to look at labs, okay? But before we get to all that, I want to just back up for a second and show you categories. And I don't have slides on this because I just wanted to write it out. I thought that might be effective. So let's look. So we're talking about the general subject of amino acids. And then we're opening up with the trick question, which is what's the most important role of tyrosine? Okay, protein synthesis. What's the most important role of tryptophan? Protein synthesis. This is just from a biochemical human physiology standpoint. What's the most important role of, I don't know, any of them? Methionine, protein synthesis. Okay, so we're starting with that as a premise. But now we're tossing that out for a minute because we've already talked about that for enough. You've got that in your brain. And now we're talking about groupings of amino acids. Okay, and when we look at the labs in a few minutes, this becomes really important. So there's groupings of amino acids like serine. Let's just group these: glycine, histidine, tryptophan, and glutamine. I'll be impressed. If anyone can tell me what that grouping is related to, someone type it in and we'll send you like, I don't know, a $20 Starbucks card or something if you know that one. That's the hard one, okay? Then there's other grouping. These other groupings are easier. So cysteine, glutamine, you should know this one. If you don't know this one, then you should keep listening because I'm about to tell you what the answer is if you don't know this one. Cysteine, glutamine, and glycine, that pairing, or tripling, whatever you want to call that, right? Oh, Jay, you got that. See, some of you guys have been paying attention for a long time. This is good. All right. Now, other groupings, well, we could just say I have a slide on it, the detox ones. That's a pretty important grouping. And then there's another grouping that you got to just memorize because this comes up all the time, which is tyrosine and its relationship to glutathione. And so glutathione is cysteine, glutamine, and glycine. So we want to, this is really a kind of a complicated way of saying dopamine, perhaps one of the more important chemicals in the human body to feel good, right? Dopamine is strongly related to sulfur chemistry and the sulfur amino acids, okay? And we're gonna look at examples of this in a minute, but I'm just throwing this out there. So now, those are the kind of questions. Now, if we look at amino acids and catecholamines, this one's easy because it's just really tyrosine is the amino acid that we're thinking about. And you can prescribe tyrosine. I give tyrosine to patients literally every day, like a lot, you know? In fact, for 12 years of my life, I worked with this neurotransmitter lab, and I had a couple thousand patients. All we were doing was tyrosine basically and 5-HTP. You know, for a dozen years I did that. I was pretty into it. So anyways, I'm pretty familiar with how to use tyrosine. And now here's the tyrosine pathway, right? Goes down to dopamine, norepinephrine, and epinephrine. But what's not on this chart is that somewhere in the middle of all this stuff, you have to have cysteine. That's a pathway that's just not represented on this particular graphic. You have to have cysteine in order to make dopamine, norepinephrine, and epinephrine. And you also have to have cysteine to make something called glutathione. So one of the pairings that you're going to see a lot is that a person has a problem with either dopamine, norepinephrine, or epinephrine, most often dopamine, and they have a cysteine deficiency on the lab, and they also have a glutathione problem. Those come together very often. This is an every day of the week kind of thing. So you want to treat them with tyrosine, but if you don't correct their cysteine, they're not going to get better. Well, they'll get a little better, but not that much better. And they will stay with you. They'll come back and they'll say, yeah, I'm better, but they're not really better. Okay, and I've made that mistake. I can speak from experience. having made that mistake many times. Okay, so then here are the amino acids and toxicants. So if we look at this list, I mean, you can't turn around without hitting an amino acid in detox here. Like, first of all, here's glutathione, and that's made from cysteine, glutamine, and I was going to say glycine. Yeah, glycine, cysteine, glutamine, and glycine. And then you also need for phase 2, methionine, cysteine. See these guys here? Methionine and cysteine, glycine and taurine, glutamine. Those are all amino acids. So basically, without the amino acids on the page here, you can't really eliminate waste products. Your detox pathways don't work. So your brain doesn't work without tyrosine and tryptophan. Your detox pathways don't work without those amino acids. You need arginine in order to have a healthy heart. Healthy blood vessels require arginine. Arginine is involved in producing nitric oxide, which is a very heart-healthy gas. Okay, and if you want to read about nitric oxide, I think it's a fascinating story. There's a Nobel Prize in medicine was given out, I don't know, like 20, 25 years ago to the doctors, the researchers that located this molecule called nitric oxide. And if you just Google Nobel Prize in medicine, nitric oxide. You can read about that all day long. It's a really fascinating story. But in the subsequent decades, there has been an untold number of research studies. You can never read them all about how nitric oxide affects your heart. Here's one of like thousands and thousands of studies. Anyways, it turns out that arginine is extremely important for cardiovascular disease prevention. And that's a nice little article about that. And then here, I want to show you this. So now I'm going to focus on a couple of things tonight. This is one of them. So this is the relevant sulfur-containing amino acid pathways. Sulfur-containing amino acid pathways. So the end result of all these pathways is that we are making glutathione. And here's our cysteine. And then here's homocysteine and methionine. Did I just say homocysteine? Does that sound like cysteine? Kind of does. It has cysteine in the actual word. Homo for homologous and cysteine. So when they say homocysteine, it means like, yeah, this is kind of almost just like cysteine, but we're going to call it homocysteine because it's a little different. Some biochemists sat down and decided that. So homocysteine and cysteine. So if you're low in cysteine, you can't make glutathione adequately. If you're low in cysteine, it's going to screw up your methylation. Okay, the other amino acid that's really important for methylating is methionine. And so your body's just trying to do its job, and it's cranking along here. Up here we have methylation spinning around. Methylation is your body taking homocysteine, converting it to methionine, and then these methyl groups go firing off into space, and they do all kinds of wonderful things, right? They build membranes for your cells. They make energy, we call it creatinine. They make hormones. They like totally, control your DNA. I mean, there's all kinds of important things that are happening because this methylation cycle is working here. But it's completely dependent on sulfur amino acids. And so we also depend on those same sulfur amino acids to make glutathione, okay? And here you can see your taurine, your cysteine, your methionine. These are all amino acids. So methylation is completely dependent on methionine. That's kind of what methylation is, right? Is turning methionine into homocysteine and then back again. And glutathione is completely dependent on cysteine, glutamine, and glycine for its production. All amino acids. And then taurine you can toss in here too, right? So there's a whole bunch. So in other words, in order to protect the body and make antioxidants like glutathione, you need amino acids. In order to methylate, you need methionine for the actual methylation cycle itself. And then I'll show you in a minute some of the other amino acids that are required. So in other words, if the person has a methylation problem, MTHF whatever, it doesn't matter. If they don't have methionine, they could have all the genes for this problem, none of the genes for the problem, it doesn't matter, right? If they don't have methionine, it doesn't matter what's happening with their B vitamins, nothing's gonna work. So if you get patients and they have MTHFR and you give them B vitamins and they don't get better, maybe you should think about methionine, cysteine, taurine, glycine, all these amino acids. And well, you have the whole boot camp. That's the whole point of the boot camp that I taught in the spring, is this amino acids and B vitamins connection. These two things have to work together. Amino acids are pretty much useless without the B vitamins, and the B vitamins are completely useless without the amino acids. So you have to have, anytime you even thinking about giving someone a B vitamin, you have to know what's happening with the amino acids in order that the B vitamin can work properly. And most people don't take the time to do that. They just look at the B vitamin issue and they don't look at the amino acid part of it. And again, we've talked about this 16 times already, but glycine, glutamine, and cysteine are the three amino acids you make glutathione with. And then here are the amino acids that we're tying back into the methylation. All right, so again, we have methylation up here. Here we have homocysteine. And then here we have methylation substrates, methylation products, what we're making, and the single carbons chugging along. So, and then here's our B12, and then here's all the folate related things here. Okay, and so folate takes all the news, right, in terms of methylation. But what's really happening is single carbons are getting processed and then tossed around out as methyl groups, which is CH3, right? But basically, we're getting single carbons and we were throwing them around so they can go places and do things. That's what methylation is. And those single carbons have to come from somewhere. And guess where they come from? Serine, glycine, histidine, glutamine, sometimes called glutamate, glutamine, and tryptophan. Okay, so let me say that again. In order to methylate, you have carbons here. You want to get them into the single carbon pool. It's kind of like a swimming pool full of carbons, right? And then you want to sling those carbons out into the world in the form of a methyl group. And that's what a methyl group is. It's a single carbon with 3 H's. And then they go and they do things. They go and they control your DNA and your hormones and neurotransmitters and detox. So the actual methylating thing is a single carbon, and that carbon is coming from serine or glycine or histidine or glutamine or tryptophan, which are all different amino acids. That's what's leading to this process. And of course, the folate part is super important. That's the whole blue thing in here. Okay, the folate part is absolutely critical for making all this thing happen. But if you don't have the amino acids, folate, even the best, quality folate supplements, just going to be like, nothing to do, right? There's nothing to move around. There's nothing to do. So amino acids are really important. And then, oh yeah, then I'm going to talk just for a moment. We have time. Oh, okay, we're right on time. Good. So I'm going to talk just for a moment about the protein functions of amino acids. And I want to show you some examples. So we mentioned this in the very beginning. We talked about protein functions, then we talked about non-protein functions. Now we're back to talking about protein functions. Then we're going to look at labs. So protein functions of amino acids. You need all 20 amino acids to make proteins. And what proteins are we talking about? All proteins. So here's just an example of proteins. Digestive enzymes, you have to have all 20 amino acids. Transport proteins like hemoglobin have to have all 20 amino acids. Structural proteins, glycine, collagen's a little different, but these others need all 20. Hormones like insulin require all 20. Defense, immunoglobulins, kind of a hot topic these days. You have to have all 20 amino acids. You can't make immunoglobulins properly. And I'm going to just show you some examples here. Collagen's a little different. It's got this other structure, so we kind of hold that out separately. So you just kind of put that in the back of your mind somewhere. But storage proteins like hemoglobin, you have to have all 20 amino acids. Hormone proteins like insulin, you have to have all 20 amino acids. So you could have a tryptophan deficiency that messes up someone's insulin production. You could have a tryptophan deficiency that leads, because it's one of the 20 amino acids you need to make all proteins, and insulin's a protein, that could interfere with a person's blood sugar. And if you guys, some of you have probably been in practice for a really long time, and even if you just have been in practice for a year, you've already had a few people like this, where the patient just walks in and they have like 1,600 different problems. They're tired and they're depressed and they're hair, skin, and nails doesn't look that good, and they haven't had a sex drive since 1962, and they haven't had, you know, any joy in their life for a really long time, and they hurt everywhere, and they're achy, and they walk up a flight of stairs, and they're even more sore, and they've been to 15 or 20 doctors, and no one knows what's going on with them, right? And so when we have patients have global problems like that, what could be one of the problems that would cause problems all across the body? A lack of amino acids would cause you to not detox well, would cause you to be achy, sore, and stiff everywhere because you're not making enzymes properly to clear things like lactic acid, would cause you to not burn body fat because you can't make the enzymes to burn body fat, so you're going to gain weight. So the more symptoms that the person has in a way, the more likely they are to have a basic problem like low amino acids. Just can't, I mean, there's some people that come into my practice, it's like you couldn't have that many individual problems. They have 1,600 different symptoms. They don't have 1,600 problems. They probably have like 5, right? And this is one of the central issues in human physiology is just so making sure your patients can make things. When we talk about healing and the repair process, that's making proteins, right? That's what healing is being able to make proteins. So another category, immunoglobulins are proteins. All right. So now we're right on time. I'm going to talk a little bit about the class, and then I'm going to look at labs. Or we're going to look at labs. But first, I'm going to get a glass of water because I'm staying well hydrated. I hope you are too. And if you're wondering, which you're probably not, but I'll just tell you anyway, since we're taking a little break here. I'm doing intermittent fasting now. So I eat dinner around 6 or 7. I have popcorn for a snack. I'm admitting that because the kids got me a popcorn maker, but not a little one, but like a big one, like you see in the movie theaters. They got me that for my birthday. I was wondering, like, they gave me this huge box. It was like the size of a truck. I'm like, what's in this thing? Is this like a joke present? And then I opened it up, and it was a popcorn maker, like in the movie theaters. So we make popcorn at home a lot. But anyway, so I do have popcorn. But besides that, then I don't eat again until 2 or 3 the following day. So I've been doing this for a while now. It feels really good. But it means you end up drinking a lot of water. Okay, that's enough for a break. Now let's go back. So, okay, Lab Interpretation Bootcamp. This is coming up in a couple weeks for those of you that want to learn more about amino acids. It's a 2-month course. We're doing case studies. There's 4 live calls where we're going to review the cases that I'm presenting that are from my practice. You get to ask questions during the calls. We're going to have, it's a pretty intensive curriculum. There's lectures that I've done about how to interpret labs. So they all focus on lab interpretation. And then there's lectures that Richard Lord has done. I think I limited it. I had hundreds of hours, but I think we pared it down to like maybe 10 or 12 hours of Richard lecturing. But just getting through an hour of his material is just so intense that you'll see what I mean if you join the class. So anyways, we got more Richard Lord in this than you would ever imagine. It's incredible. And he's the genius behind all this work that was started, decades and decades ago. So you'll want to hear his stuff. And then let's see, what else about the class? Yeah, it's going to be good. We did the first version of it in the spring. This is a second version, and focusing a little bit more on in-depth lab interpretation, and there's, I think, 4 case studies that we're reviewing that are all related to the stuff that we're talking about tonight, okay? And you get 20% off if you use that discount code, so you guys can go and sign up. All right, now let's take a look at cases. Now, hopefully this is starting to make a little bit of sense. All right, here's a patient. And first of all, we see their amino acid levels. Lysine, methionine, tryptophan. This is an ion panel from Genova Labs. They also have Nutraval tests. I can show you one of those too. Here's a Nutraval, very similar. Let me just skip to the Nutraval part, the part that has the amino acids. Sorry, here we go. Make that a little bigger for you. This is a Nutraval. Same basic format, arginine. I mean, maybe list them in different order, but it's the same amino acids that they're measuring, right? Either way you want to do it. So either order a Nutraval from Genova or you can order an ion panel from Genova. They're basically interchangeable. And what we're looking at are what amino acids are low and what does that mean? So right off the bat, we see lysine, methionine, or outright low. No, lysines borderline low. They're in the first quintile, let's say, borderline low. Phenyalanine's actually outright low. So that's 4 already. Arginine is like borderline low. It's 5. And then they group them. Neurotransmitter-related amino acids, you can see there's a cluster there. 3 of those are borderline low. Oh, and there's our methionine low. Oh, and there's cysteine low. Well, this is getting interesting, right? Now we're thinking about what do these do? Glutamine is low. That's not good. And glycine is okay. So we just learned 3 of the amino acids that make glutathione, cysteine, glutamine, and glycine. This person has 2 of the 3 low. And what is arguably one of the most important things in the human body? Glutathione. It's what keeps us alive, right? It's what keeps us from dying. It's what keeps our cells from dying. So then we can skip forward to the part of the test that looks at, let's see here, I'm trying to find it. Here we go. Skip forward to the part of the test that looks at the dopamine marker. Remember I talked about this a minute ago. Homovanillate is an indicator for dopamine, and the dopamine levels are low. Remember how I said you're often going to see glutathione problems paired with dopamine or epinephrine or norepinephrine problems? Why? Because cysteine is an amino acid that you need to make dopamine, and cysteine is an amino acid that you need to make glutathione, and cysteine is not adequate in this person, right? The levels were low. Cysteine or cystine, those are interchangeable, right? That's just one example. These are just random cases that I pulled out of my like random cases file, okay? Let's look at a NutrIval. So here we have amino arginine is low, borderline low. See what else? That's the only one. Oh, arginine. Oh, and cysteine or cystine. Again, cysteine and cystine are interchangeable. So arginine and cysteine. So now let's look at, let me just show you one other thing that when you see arginine low, now you're thinking, nitric oxide, that's not good for your heart, right? If arginine is low, because now you have low nitric oxide. And then there's another marker that you look at, and this is a little confusing because they're not together on the test, and you're just supposed to know this somehow. But arginine, one of its major roles, here we go, sorry. One of its major roles is to help with the clearance of ammonia. The other major role is to produce nitric oxide. And so here are the urea cycle markers. Okay, the urea cycle is how the body dumps ammonia out. If you can't dump ammonia out, then you get ammonia building up in your brain and you don't feel very good. If you have a genetic variance that causes this, it could be life-threatening pretty seriously for a young baby. And so arginine is part of the urea cycle, okay? So is citrulline and ornithine. And look at this, citrulline is actually high, arginine is low, and ornithine is low. How could that even happen? It's a good question. Well, probably because there's some genetic problem here in the urea cycle of this particular patient. And I don't know, I was in practice for over 20 years till anyone really explained this to me. I don't know why it took me so long. But if you guys haven't heard of this before, then I promise you will see this on a regular basis in your practice, because now that I know how to spot this, I see it all the time. Not every day, but every month. I have at least one good ammonia toxic patient every month, at least, and sometimes more, but yeah, at least once. Let me just show you an image here of the actual urea cycle itself. I've got some, hang on, give me 1 second. Let me find the right one because this one is really good. I didn't really anticipate this, sorry, because I didn't look at these cases ahead of time. I just randomly picked them. Let's see, let me show you though. Here, this will work. It's perfect. There's prettier diagrams, but this will do the trick. So when you see a variety of disruptions in the urea cycle, here. Now, this is a good one actually, because you can see the whole thing. So when you see a variety of disruptions, remember two of the markers were low and one was high. That's really suspicious because they should be either all low or all high. There should be some coordination here. And here's our ornithine, here's our arginine, and then here's our citrulline. Okay, so your body has ammonia, it needs to get rid of it, and it needs to have all these different enzymes that are run by, and here are the enzymes in the blue, in the green here. Okay, here are the enzymes. So it needs all these different enzymes in order to clear the ammonia. And that whole clearance issue is carried out using these amino acids, ornithine, citrulline, and arginine. So if you see some of these amino acids that are low, they're down, right? And one that's high, and think about it, this is a cycle. You can see what's happening. So if there's a roadblock, there's an enzyme that's busted up, you can have a buildup of one of these amino acids, and then downstream, you'll have levels that are low. Does that make sense? It's just like a traffic jam, right? If there's a car accident right here, you have a backup of cars behind the car accident, but in front of the car accident is not a lot of cars. So if you have a backup and an enzyme's broken right here, citrulline would go high, but then arginine and ornithine would be low. That's a genetic disorder. That's a problem with the enzyme. Or it may not be genetically based. It could just be that something damaged that enzyme, right? It may not be genetic at all. It could be damage to an enzyme. I was just reading about this afternoon. When Dr. Lord and I were talking about this, is that there's hundreds and hundreds of enzymes in the body, and they're very susceptible to damage from environmental toxins. So you could have an environmental toxin that's damaging this enzyme here. That would lead to citrulline going high and arginine and ornithine being low. Or there could be a genetic defect with that enzyme. Kind of, I don't know if it matters a lot which one it is, but look at the lab now, and you see this on the test, okay? Once you learn these pathways and then you look at the test, then it all makes sense. So where's our one that's high? There's citrulline. Remember, that's where the car accident happened. That's high. And then in front of that enzyme, we have our arginine that's low and ornithine that's low. You now know exactly what enzyme is messed up. It's the one that processes citrulline into ornithine. You can go look it up on a chart like I just showed you. Okay. And you got to fix this. This is like not an optional thing to fix. You got to make it so that person can make nitric oxide and that they can clear ammonia. And what would you do? You would give them arginine, right? You might even give ornithine or some amino acid formulas that will lead to ornithine production. And then you kind of go on a wild goose hunt to figure out how you're gonna, fix the citrulline problem. Is there a genetic issue there? You can investigate that. Is there a problem with environmental toxins that are damaging enzymes? Is there a lot of oxidative stress? You have to fix all that, But I'm just showing you how to identify things now and how bloody cool this is. Isn't that amazing? You can see all that? On a lab that doesn't look like there's a lot going on, you're like, why is citrulline high? That's a little strange. Why would one amino acid be high? Have the whole section there. And then why is this one low? And are they related? And what about the arginine? Okay, so let's put this again, putting this together one more time. Let me just show you. Okay, now going back to our picture I grabbed off the web, just to show you guys can do this. I have 100 pictures of this that are in my PowerPoint. So I'm just showing you could do this on your own in 10 seconds. Citrulline was high, right? That's where the backup is. That enzyme is broken. Either it got nuked by a toxin or the person was born and it was messed up the day they were born. I don't know, check their family and see what's going on. Test all the family. And then downstream from that, arginine and ornithine are low, and this is high. That's a defect in the enzymes that clear ammonia. And so what happens to people that have that kind of a problem? The ammonia gets into their brain. That doesn't feel very good at all, not even a little bit. And every single ammonia toxic patient I've had in the last couple of years writes on the same words on their patient forms. They always write the same thing, brain fog. They always write that, brain fog. These people don't know each other. They have no relationship to one another. And they always say, I have brain fog. I'm like, what's wrong with you? I have brain fog. So apparently, when you have an ammonia buildup in the brain, you feel like your brain is foggy. That is what pretty much everybody says. All right, let's see. We have gone through 2 cases. Did I do the first one? Yeah, I did 2, right? Okay, so let me just show you what we try to do in the class. So, and then we do this in the mentorship 5 hours a week. We do this in the boot camps like an hour every couple weeks. But basically we, meaning I, design programs. And so I'm just gonna do one right now. I'm gonna show you exactly how this would play out. So that first patient, and I still design all my patient programs from scratch. I know I could just turn it into like a template and hand it to people, but I like to do everything from scratch. I like to make my own vegetable juice. I made some really good squash soup last night. I just do everything from scratch. Okay, so that first patient we had, we're gonna remember back. Remember they had a tyrosine problem. So you're gonna, unsurprisingly, give them tyrosine, and you're gonna start them with 3,000 milligrams a day. So it's 1,000 milligrams of tyrosine breakfast, lunch, and dinner. And then we said, and we saw that they had a cysteine or cystine problem. So you're going to give them NAC, or you could use glycine, or you could use glutamine, or you could use all 3 of those, or you could just give them glutathione and NAC, any of those combinations, right, to get the sulfur compounds up. How much? Well, let's say any of those would come in a 500 milligram, but not the glutathione. So let me take the glutathione out of there. Then you would give usually like around, let's say 3,000 units of those a day too. If you're doing glutathione, it would be a different amount. But NAC is better anyways, because this person was low in cysteine, right? So let's stick with that. And NAC would be the preferred one. You could look at the lab in more detail and see, oh, maybe they're low in glycine too, okay? So NAC would be preferred though. And then you have to give B vitamins, a B vitamin, B complex, in order to make this whole thing work. And then you should just, for good measure, have them on a multivitamin that's all genetically approved and everything, that's good for you, right? And so this will get their dopamine levels up, get their sulfur compounds up, and this is the heart and soul of this program, is all amino acids. All right, and let's think about patient number 2. They had an arginine problem. Now we're going to figure out what enzyme is it that's busted up. You're going to figure out, is it genetic? Is it environmental toxin related? Oh, it's mercury that's causing it, or oh, it's like, I don't know, DDT or something that's causing it. So you're going to get the chemicals out. There's other things you're going to do, right? We're just doing a little subset of what you're going to do. But arginine, again, comes usually in 500 milligram capsules. And then you want to do, I usually just break that in half. So we do 3 in the morning, 3 with dinner. You could do them on an empty stomach if you want to get all careful about it. Ornithine. Most people don't just supplement ornithine. Usually they would use a free-form amino acid formula. You can get ornithine. It's a little obscure of a supplement, so usually people use free-form amino acids, like 1 to 2 teaspoons daily. That usually comes in a powder. And then to make the amino acids work, remember, you have to always give B complex. And then what are you doing with this patient? You're getting them to improve their nitric oxide, which would be good if they have a heart condition, if they have high blood pressure, if they have a history of high LDLs and they're on statins, and they never had a heart attack, but they had some chest pain and they're worried about it, So arginine's super important for the blood vessels. Google Nobel Prize in medicine, nitric oxide. You should read about that. Do that in the next week or two. And then arginine also equally important for getting rid of ammonia. And we saw how arginine and ornithine were low, so we want to supplement with them. And the citrulline was high. So what do you do about a high amino acid? What do you do about a high amino acid? I don't know. Is anybody going to chime in? Okay. Another way of asking the question is, what helps break down amino acids? Well, in this case, it's an enzyme defect, but still, you want to break it down better, right? You use B vitamins. Thank you, JE. You use B6 with a B complex. So B vitamins will help you metabolize or break down the stuff that's building up. All right, and let me show you one other thing here. So, see, Catherine is asking, where do we find good amino acids? And it really does matter where you get these things. So there's two companies that I buy all my stuff from. And both these companies help support our educational efforts as well, which is great. I guess they're sponsors. It sounds so official, but they're sponsors, Pure Encapsulations is the one. Okay. And they have, it's a professional brand. If you're a doctor, you have a license, set up an account with them, you can start ordering this stuff. It's best quality products on the planet, Pure Encapsulations. They've been around for a long time. They have a huge history. If you haven't heard of them, you can read about their history and see what they've been up to for the last decade or two as they've been doing this stuff. And pretty solid company. It's not going to get better than that. And then the other company that I use is called Designs for Health. Okay, so those are the two that I order from. All right, let me see. I'm going to go through some other questions here. I'm going to remind you guys that we have this class coming up, and here's the discount code. And let me try, we got a couple minutes left. And so let me get to the other questions. Yeah, so it's a question about pure encapsulation. So I know and I work with the people there and have done for many years. They're actually really extremely good friends of mine. Nathan Morris, Kara Ware, Paul Larkin, the whole crew over there. Juniper is the main science person, and they're doing some of the best product development, quality control, and production around, and they were good before, and they're probably even better now from what I've seen. I've been to their factory. I've met the guy that, actually brings the trucks in and unloads everything. I've seen all the people walking around with the white jackets that are making the stuff, and they're on it. They're on it as any company can be. So I trust them with my practice, literally, right? Because they order their stuff every day, and they weren't doing the right thing, I'd be in some serious trouble. Okay, let's see. Can citrulline be used to increase nitric oxide? Absolutely, yes. Yeah, Robert, he's always asking the best questions. Robert is one of our students from the mentorship. Robert, you always ask the best questions. Absolutely, yes. And there's research on that too, if you want to look it up. So there's studies on citrulline being used to increase nitric oxide. And you could absolutely use citrulline instead of or along with arginine to improve nitric oxide. Yep, I was just reading about that series of studies that were done on that. Okay, so that's an absolute yes. Let's see, we got, let's see. I'm gonna make sure I get through all the questions here. I may miss one or two because there's a bunch that are coming in here. Oh yeah, so this is always a question of what's the variability in these labs? Like with an organic acids test, what would it be like tomorrow with an amino acid test? What would it be like next week with a fatty acid test? What would it be like in 3 weeks? But there's always like the kind of dental floss problem, right? Which is I'm a victim of, or a perpetrator of, I guess. I'm a perpetrator of this, where you're getting ready to go to the dentist and you're like, oh, I got to see the dentist next month to get my teeth cleaned. And then you start flossing a lot, right? And you're just hoping that you get enough flossing in that she doesn't notice that you haven't been flossing for the previous 5 months since you had your teeth cleaned before, right? And so people do that too. Like, oh, I'm going to do this nutritional test. Now I'm going to eat really healthy, for 2 weeks before I do the test, and I was eating junk food for like 16 years, and then now I'm going to eat really healthy for 2 weeks. So there's definitely kind of this dental floss issue thing that happens where people get on their best behavior before the testing. And so the variability, first of all, you want to let people know, don't change your diet, just eat what you've been eating and just do this test tomorrow, right? So you don't give them time to make anything different than it was. You want to see, get an accurate sort of read on what's actually going on with them. And then the second part of that is that there is variability between markers, and this has been studied extensively. People have actually done research studies where they do these tests once a week for 12 weeks on 200 people, and they see what the variability is. And there's even published studies on this that Richard Lord has done on each organic acid marker and how it varies over the course of time in people that they tested over and over and over again and over again. And we don't have time to get into it, but some of the markers are more accurate than others. Amino acids, you're not really going to have a problem unless, I mean, they're going to be accurate unless the person took an amino acid supplement right before doing the test, or if they loaded up on like protein shakes or something the day before. That would skew the results of the test. So you definitely want a person eating a normal diet and then doing the test fasting, and you're going to get a pretty accurate result from that. Okay. I think, and let's see, one more question about supplement. So when you're doing the amino acid combination products, you can use both the single ingredient products and the combination products together. It's usually done that way. Can you just give liposomal glutathione? Absolutely, you can use glutathione also, but remember, if they're low in cysteine, what's the main role of cysteine? That's a trick question. Protein synthesis. So if they're low in cysteine and you give them glutathione, you didn't give them cysteine, so they're still going to have a problem with protein synthesis. What proteins? All proteins in the human body except for collagen, right? So if they're low in cysteine, you have to give the cysteine. Why? Forget glutathione, that's really important, but because of protein synthesis, you have to do it. You can then also layer on top of that glutathione, but glutathione is not involved in the synthesis of all proteins. It's just the world's most important antioxidant, right? So you need to start, and this I'm still struggling with this. You need to start to think when you hear an amino acid, if it's one of those 20 amino acids, you got to think protein synthesis as the first role, okay? All right, let's see. I think we got all the questions for the most part. Let me just double check here. Oh, a couple more came in. Oh, Dr. Lord's book is called Laboratory Guides to Health by Richard S. Lord. You can buy it as a Google Books and you can buy it as an Apple book. 2 ways you can get it. All right, I think I'm going to wrap up for now. We're right on time, or we're a little over time, a couple minutes over. Thank you guys very much. If you're interested in taking the class, contact our office. And we'll be having more of these lectures coming up. It's a mini series, right? So there's more of them coming up. I don't know when, but you can check the schedule. It's probably in a couple weeks. We'll have another one of these, or just check your email. We'll be emailing you guys out, whatever the next one of these free classes is. Okay, take care, everyone, and bye for now.